It's been a while since we found some missing angles, so I wanted to give you quite a few of these. There's 9, 10, 11 on page 1, and on page 2 there's 12 through 16. And these are all pretty much the same exact type of problem. We're asked to find a missing angle when we're given a right triangle and some of the information, either a couple of the legs or a leg and a hypotenuse. We'll do number 13. Again, knowing the trig ratios is very helpful here, right? Sine, cosine, and tangent. We're trying to find this angle that's labeled with the question mark. I'm going to call it angle theta because I just like the look of that variable. That's better looking. So for this one, you can see from that angle, this is my opposite leg, and right next to it here is the adjacent leg. So when I have the opposite and adjacent and not the hypotenuse, that's the tangent ratio. So I can say that the tangent of my angle theta is equal to 5/6. And now if I want to solve for theta, right, I need to use my inverse trig function. So right below this, I like to write that theta is the inverse tangent of 5/6. You can see I'm applying the inverse tangent to both sides there. On the left-hand side, it leaves me with just theta. On the right-hand side, I have the inverse tangent of theta. And I can grab my calculator, and just to review how that looks, the inverse tangent is I need to get access with my second function key. So I hit second and then the tangent button. So you can see I've got the inverse tangent of 5 divided by 6. Close the parentheses and equal. You can see that it says that theta is approximately, let's see, I'll round this to, I guess, just the nearest tenth, 39.8. And they didn't give us any units for these, so we'll just say 39.8. Up above, did it say, yeah, it says round to the nearest degree. So if I'm rounding to the nearest degree, my answer should be, it's about 40. This would be incorrect because we're supposed to round to the nearest whole number of degrees. So most of these are going to look just like that. For number 15 here, you can see this is the hypotenuse, and this is the adjacent leg. And here is my angle theta. This is what I'm solving for. So hypotenuse and adjacent over hypotenuse, that's the cosine ratio. So I'd say cosine of theta is equal to adjacent over hypotenuse. And then therefore theta would be the inverse cosine of 6/7. And you can figure that out. And then finally, the last couple questions, probably we should have had more of these. You'll notice that in almost all these diagrams, there's actually, in all of them, there's parallel lines. And in every single case, these parallel lines are cut by a transversal. Here's the transversal. It's traversing the parallel lines going from one to the other. And when that happens, right, there's always, angles that end up being congruent to each other and angles that end up being supplementary. They add up to 180. So look at them closely. If you're not exactly sure about the relationship, you could use a small piece of patty paper to convince yourself which angles are supplements and which angles are congruent. But you just need to write 4 pretty quick equations and solve for x. Again, for all of these exercises, I'm looking for accuracy. These are things that you can get 100% correct. So please take your time, be careful, and go for 100%. Have a great afternoon and have a great weekend. This is Mr. Roberts.